All right, hello. Welcome. I wanted to continue reading um, The Cathedral and the Bazaar by Eric S. Raymond. And we did the preface a few days ago, and now we're going to move on to effectively chapter 1. It doesn't seem to have chapters in the classical sense, but we're just going to continue on with what we have. So what we have here is a brief history of hackerdom. So, a brief history of hackerdom. I explore the origins of the hacker culture, including prehistory among the real programmers, the glorious days of the MIT hackers, and how the early ARPANET nurtured the first network nation. I describe the early rise and eventual stagnation of Unix, the new hope from Finland, and how the last true hacker became the next generation's patriarch. I sketch the way Linux and the mainstreaming of the internet brought the hacker culture from the fringes of public consciousness to its current prominence. I don't if in case some of that's unfamiliar to you, in the early days of the internet, MIT was where a lot of the movers and shakers were from. It started as a Defense Department project called the ARPANET, and while it wasn't the first mainframe and time-sharing operating system, Unix rose during that time. And when he says a new hope from Finland, he's referring to actually Linux and Linus Torvalds. So here we go. Prologue. The real programmers. In the beginning, there were real programmers. That's not what they called themselves. They didn't call themselves hackers either, or anything in particular. The sobriquet real programmer wasn't coined until after 1980, retrospectively by one of their own. But from 1945 onward, the technology of computing attracted many of the world's brightest and most creative minds. From Eckert and Mauchly's first ENIAC computer onward, there was more or less continuous and self-conscious technical culture of enthusiast programmers, people who built and played with software for fun. The real programmers typically came out of engineering or physics backgrounds. They were often amateur radio hobbyists. They wore white socks and polyester shirts and ties and thick glasses and coded in machine language and assembler and Fortran, and a half dozen ancient languages now forgotten. From the end of World War II to the early 1970s and the great days of batch processing and the big iron mainframes, the real programmers were the dominant technical culture in computing. A few pieces of revered hacker folklore date from this era, including various lists of Murphy's Laws and the mock German Blinkenlights poster that still graces many computer rooms. So, yeah, you may not have heard of some of these things, but if you Google Murphy's Laws and the Blinken's lights, it's a faux German poster that talks about what you should and shouldn't do in a computer room. It's kind of adorable. Yeah. And the Murphy's Laws, although Murphy's Law is one thing, I do believe that in the hacker culture, they kind of played with that and came up with additional ones that they adopted. So one of the things he's going to talk eventually about is something called the jargon file, which is an interesting document that came out of that time period. If you search for it, you can find multiple versions of it. But basically, if you read through it, it's this whole big thing about hacker speak and technical jargon and that kind of stuff, and it's incredibly entertaining, and you can definitely feel a lot of the influence of that kind of stuff that's come down to us even today in the culture of hobbyist programmers and such. So if you want to get to know where these old guys who used to program in assembly and even punch cards and stuff like that, the jargon file can give you a lot of insight. They're very interesting folks. So anyway, continue on. Some people who grew up in the real programmer culture remained active into the 1990s. Seymour Cray, designer of the Cray line of supercomputers, was among the greatest. I don't know if that's really remembered in the current zeitgeist, but back during the 1990s, a Cray supercomputer was an incredible thing to have if you were a national lab or a prestigious university or something like that. And I still remember famous pictures in magazines and stuff like that you could see of these mainframes, and they almost looked like some modernist architecture because I remember one. It was like arranged in these like columns, and it almost looked like they had some sort of couch or cushion around the bottom side of it. I didn't, as a young man, I didn't understand what that was all about. And these people still, even though they were highly technical, they still had a sense of aesthetics, even inside of those rooms where essentially no one was ever going to see it. Seymour Cray, designer of the Cray line of supercomputers, was among the greatest. He is said to have once toggled an entire operating system of his own design into a computer of his own design through its front panel switches. In Octal, without an error, and it worked. Real programmer Macho Supremo. In case you aren't aware, Octal, that is that's a way of writing numbers. In the computer, of course, runs in binary, zeros and ones, and so that's a base 2 system. So you only have 2 digits, 0 and 1. But so that you don't have to write out all 8 bits at a time, they came up with different systems that more or less corresponded pretty well to binary. And octal is one. It's got 8 digits, 0 through 7, and so that can represent, I believe, essentially 8 bits. And of course, hexadecimal is probably the more well-known one, and the reason that's so useful is because you can represent 16 bits with one character, and so the reason they picked octal and the reason they picked hexadecimal because those are, of course, powers of 2, so it directly corresponds to a pattern in binary. Anyway, okay, moving on. The real programmer culture, though, was heavily associated with batch, and especially batch scientific computing. That essentially means that they just had a lot of processing to do, and they would just run it. They would get it together, get what calculations they needed together in a big lump, and then just run them. It wasn't. There was no concept of like not really of an operating system or anything like that. It was just a computing machine computes, and we want to get the computed information out of it, and that's all we want to do. But what the story he's starting to frame is the idea that we started to move beyond that, beyond just this simple batch processing into what can this neat toy do for us? How can we interact with it? What kind of stuff can we do with it? Anyway, so the real programmer culture, though, was heavily associated with batch, and especially batch scientific computing. It was eventually eclipsed by the rise of interactive computing, the universities and the networks. These gave birth to another engineering tradition that eventually would evolve into today's open source hacker culture. Now, if there's anyone relatively non-technical watching, open source essentially means it's public. It's a public collaboration. It's not being developed under high security. It's not being developed behind closed doors. The primary point of open source is people want a functional product that's reliable and trustworthy. So they don't mind if it has public scrutiny or not. And in fact, as you'll see, as we see later in the book, public collaboration, open access, has some unique features that can really accelerate development if people are invested and actually want that product to work. Open source hacker culture. The open source is of course opposed to closed source, where someone owns and keeps tight control over who gets to see the source code of their system. The early hackers. The beginnings of hacker culture, as we know it today, can be conveniently dated to 1961, the year MIT acquired the first PDP-1. The Signals and Power Committee of MIT's Tech Model Railroad Club adopted the machine as their favorite tech toy and invented programming tools, slang, and an entire surrounding culture that is still recognizably with us today. These early years have been examined in the first part of Stephen Levy's book, Hackers, 1984. So that's the picture. 1961, MIT. They have a club. They have a club named the Model Railroad Club, and that club spawns the Signals and Power Committee, which starts playing around with computers. Okay, cool. The PDP-1 it apparently is a product of what was one of the big computer manufacturers of the day. You might expect me to say IBM. No, this is a company called DEC, Digital Equipment Corporation. MIT's computer culture seems to have been the first to adopt the term hacker. The Tech Model Railroad Club's hackers became the nucleus of MIT's Artificial Intelligence Laboratory. So they were already thinking about artificial intelligence back in the day, but artificial intelligence here in 2024 has become, you might say, significantly different than what their concept was in the beginning. I mean, maybe not, because the idea that you could, make a machine that can do logical operations, make logical decisions, that can calculate things, suddenly you start thinking about, well, this thing is smart. Where does that fit on the spectrum of intelligence? So they may have had some idea of, mimicking human intelligence and that kind of stuff, like they seem to be implementing today with OpenAI and these large language models and all these various other things. But at the time, they were concerned primarily with just logic, logical constructs, if-else statements. How do we process procedural flow and get the computer to make decisions, based upon, rules. The world's leading center of AI research into the early 1980s. MIT's computer culture seems to have been the first to adopt the term hacker. The Tech Model Railroad Club Club's hackers became the nucleus of MIT's Artificial Intelligence Laboratory, the world's leading center of AI research into the early 1980s. Their influence was spread far wider after 1969, the first year of the ARPANET. The ARPANET was the first transcontinental high-speed computer network. It was built by the Defense Department as an experiment in digital communications, but grew to link together hundreds of universities and defense contractors and research laboratories. It enabled researchers everywhere to exchange information with unprecedented speed and flexibility, giving a huge boost to collaborative work and tremendously increasing both the pace and intensity of technological advance. But the ARPANET did something else as well. Its electronic highways brought together hackers all over the U.S. in critical mass. So you might have missed that, but basically what it's saying is that this was the first time, independently located people could effectively collaborate. I mean, you could pick up pick up the phone, or send a telegram, I suppose, and they might have even had fax machines, but now what we have is, we can actually send information, actual, computer code and text files and that kind of stuff. We can send them. You don't have to have a typist on the other end or something like that. You can actually just send them the text. It was huge. Its highways brought together hackers all over the U.S. in a critical mass. In particular, the first version of the jargon file. The jargon file was one of the very first things that was widely distributed on the internet. Developed a cross-net collaboration during 1973 to 1975. This slang dictionary became one of the culture's defining documents. It was eventually published as the Hacker's Dictionary in 1983. That first version is out of print, but a revised and expanded version is the New Hacker's Dictionary, MIT Press, 1996. Hackerdom flowered at the universities connected to the net, especially, though not exclusively, in the computer science departments. MIT's AI and LCS labs made it first among equals from the late 1960s. So, in this paragraph, he's listing out a few of the most influential entities in the early internet. We already have MIT. We already know they're a player. But Stanford University, they had an artificial intelligence laboratory. It was SAIL, the Stanford Artificial Intelligence Laboratory. Carnegie Mellon University became nearly as important. All were thriving centers of computer science and AI research. So again, from the very beginning, we're talking about AI. And why would that be? This is the first time we ever had something that would seem to produce thinking, outside of a person. Okay. All attracted bright people who contributed great things to the hacker culture on both the technical and folkloric levels. Excuse me. To understand what came later, though, we need to take another look at the computers themselves, because the AI lab's rise and its eventual fall were both driven by waves of change in computing technology. Since the days of the PDP-1, hackerdom's fortunes had been woven together with Digital Equipment Corporation's, DEC, DEC's PDP series of mini computers. Okay? So, what do they mean by mini computer? Well, what they mean is, a computer about the size of a refrigerator versus a computer about the size of a gymnasium, right? So by the time we get to the 1960s, moving on to the 1970s, you had capable, enterprise-wide computing machines that, significantly being reduced in size. And so for them, a mini computer is probably about the size of the desk you're sitting at, if you're sitting at a desk. DEC pioneered commercial interactive computing and time-sharing operating systems. So what is interactive computing and time-sharing systems? Well, again, interactive would be in distinction to batch processing, where you just throw data at it and you get data out, whereas you can actually have a keyboard, maybe a monitor, and actually type in things and get things back. It's interactive. Now, the time-sharing piece of that, actually, that was really interesting. My first interaction with a computer at a university level when I was about, I think, 17. They gave us an account on the on the university system. I think it was a VAX. Anyway, but the terminal, you could go find these terminals all over campus, and basically it was just a dumb terminal. It had a phone line coming out of the back. It had a keyboard and a monitor, and you could write up little C programs and that kind of stuff and run them in your account. But basically the idea is you have one computer, okay, but because this computer is running instructions at thousands or millions of operations per second, if human beings don't work very quickly. So if I'm here asking the computer to do something, it's gonna take me a good solid few seconds to formulate a thought, type in a command, and ask it to do something. Well, in the meantime, it could be processing a command from some other user. And so they have this time-sharing thing where the processor will swap back and forth between requests from different users, and that's what these time-sharing things are called. So one system, multiple users. That's where the idea of that actually came from. Was basically you didn't want to waste the time of the computer because you only had one computer. The computer's expensive, so yeah. So you had these time-sharing systems, which is kind of cool. Because their machines were flexible, powerful, and relatively cheap for the era, DEC machines, like the PDP-1 through PDP-11, because their machines were flexible, powerful, and relatively cheap for the area, lots of universities bought them. Cheap time-sharing was the medium the hacker culture grew in. And for most of its lifespan, the ARPANET was primarily a network of DEC machines. So the ARPANET started as a network of DEC, Digital Equipment Corporation, PDP machines. The most important of these was the PDP-10, first released in 1967. The 10 remained hackerdom's favorite machine for almost 15 years. So that would have been 1967 plus 15, that's 1982. Yeah. So what he's suggesting there, if you want to read between the lines, is that hackerdom started in 1967, but there was a fundamental shift that would have been occurring 15 years later in about 1982. So 1982, that's one of the watermarks, and 1967 is one of the watermarks. So I'm not sure if he's saying that necessarily, but real hackers up until 1967, and then post 1967, then we had a different kind of culture rising, where you actually had the internet and that kind of stuff. The PDP-10 remained hackerdom's favorite machine for almost 15 years. TOPS 10, DEC's operating system for the machine, and Macro 10, its assembler. Okay, so some of you might not know what an assembler is. Well, back at the time, you didn't have programming languages per se. You had, nowadays you have C, C++, C#, you have, Python, you have JavaScript, you have all these different languages that you could do various things with. Represent relatively high-level concepts, succinctly. But, early on, you didn't have that. You started with just bare metal, you had to toggle switches to get your binary data into the computer. Then they came up with fancier ways like punch cards. And after punch cards, they started moving on to what was called assembly language. And that basically means that very, very low. It's technically a language, but very, very low level. So you basically have, little tokens, little words, one or two or three letters long that represent a very specific operation. Like, for instance, move this byte, this 8 bits from storage over into the first register, then move the second set of bytes over into this other register, and then I want you to add the two and put the result into register 3. So register is just this very small memory location, very, very close to the processor. So that's essentially how early computers worked. And then people started building compilers and parsers from assembly language. So you started with assembly language and you build up to higher and higher languages, and supposedly now we're at 4th generation languages. And basically the idea is, the higher the level, 4th generation, that means you should be able to work faster and do things with less code and all that kind of stuff. But the problem becomes, in order to represent a concept, there's a minimum amount of explanation that you need to make. So you can't from assembler to say like C or C++ or Java or something like that was like a quantum leap, because it means you could think conceptually and implement designs, whereas when you're working in assembler, you have to be basically aware of the architecture. You have to think from the bare metal up, whereas with higher level languages you can work from the concept down and actually tell the computer, I want you to do this. Whereas with assembler it's all like, how do I explain myself to the computer, that kind of stuff. Anyway, so that's what an assembler is. So hackerdom's favorite machine was the PDP-10. The TOPS 10 was the operating system, and Macro 10 was the assembler. So we haven't gotten to actual higher level languages yet. But just as a tangent, Lisp actually came out of this, and it was I think it was pretty popular prior to 1982, believe it or not, and afterwards, but primarily on these machines, this type of architecture, from what I understand from some things he says later. Anyway, Lisp is actually considered the first fourth generation language, and and it's probably influenced every high-level language since then. Anyway, MIT, though, used the same PDP-10s as everyone else. Oh, excuse me. MIT, though it used the same PDP-10s as everyone else, took a slightly different path. It rejected DEC's software for the PDP-10 entirely and built its own operating system, the fabled ITS. ITS stood for Incompatible Time-Sharing System, which gives one a pretty good fix on the MIT hackers' attitude. They wanted it their way. Fortunately for all, MIT's people had the intelligence to match their arrogance. So, it's an interesting point he makes there. Humility is cheap. It's a cheap way to smooth things over and help things along. If you're going to be arrogant, you better be right. You better be capable. You better be able to do, what you claim you're able to do. Now, me, myself, my personal opinion, and I may actually come across as arrogant to some people. I suppose. I think some people have suggested or implied such in the past. But where I'm coming from is that people like their territory. People like their to be considered the top of their domain, and they don't really like to be challenged. But at the same time, I don't personally feel like anyone has the right to prevent me from learning for myself, especially if information is publicly available. So if they want to be smart, if they want to be if they want to be the top of their domain and look down from on high at all the rest of us peasants and that kind of stuff, they can do that. And sure, I'm probably never going to be as good as they are, but that doesn't change the fact that that they don't have a right to keep the information to themselves. They don't have a right to prevent me from investigating. They don't have a right for me to they don't have a right to keep me from educating myself if I want to. And I don't care what domain you're in. That's just how it is. Whether and I'm talking about publicly available information, scientific literature, that kind of stuff. Business entities and there's all sorts of reasons why you need to keep information confidential. I'm not talking about that, and perhaps that's the dividing line with nefarious and non-nefarious hackers is some people think that they have a right to go and dig through other people's information and find stuff even if someone else doesn't want you to find it. But that's impolite. If it's not your property, it's not your stuff. You can't, just because you are capable of doing it doesn't mean it's the right thing to do. But we're talking like public information and concepts and ideas and all that kind of stuff. There's nobody on this planet has the right to tell you that you're not smart enough to read a book. No, you're not smart enough to understand X. And that's just a stupid thing to say anyway. I might not be the sharpest crayon in the box, but But that doesn't mean that that you can say that I'm not allowed to educate myself. That's total nonsense. And so I encourage people to, go out, find out stuff, and even if you're going to be seen as a fool, or a know-it-all, or made fun of, or whatever, the fact of the matter is that it's your mind. No one can stop you from learning without your consent to play off of a relatively famous quote. So and I think even to this present time, that's really what a hacker is someone who just doesn't care that they are an amateur. They're going to keep on investigating and trying to learn about things that strike their fancy, even if they're not going to, even if they're going to be seen as amateurish and not as polished or professional as the others. Well, yeah, because that's just what curious people do. And that's usually where a lot of innovation and interesting things come out of. So I'm certainly not going to stop. And that's one of those things that really bothers me is like, I don't know, when you're watching this, I don't know what it is right with you, but right now in our culture, we have the term Dunning-Kruger effect seems to come up a lot, and basically it's basically a way to criticize people for trying something that they're not good at, to attempting something that they haven't already mastered. And I honestly don't understand where the harm is in somebody actually trying something new. And it's just, as long as lives are not on the line or anything like that, and that's usually not the case. Who cares if they're an amateur, if they don't know what they're doing? Just let them play around. Fresh eyes, fresh minds. You never know what might happen. So anyway, that's my tangent. Let's see if I can get to a reasonable stopping place. There's one at the end of the next page. Okay. Incompatible time-sharing system, which gives one a pretty good fix on the MIT hackers' attitude. They wanted it their way. Fortunately for all, MIT's people had the intelligence to match their arrogance. ITS, quirky and eccentric and occasionally buggy though it always was, hosted a brilliant series of technical innovations and still arguably holds the record as the single time-sharing system in longest continuous use. ITS itself was written in assembler, but its many ITS projects were written in the AI language Lisp. So here's the first mention of Lisp. Lisp was more powerful and flexible than any other language of its day. In fact, it is still a better design than most languages of today, 25 years later, and I would suggest, I'm not sure. I think he was writing this in like 2000 or something like that. So I would say he's still right, even 50 years on. Lisp freed its hackers to think in unusual and creative ways. It was a major factor in their successes and remains one of hackerdom's favorite languages. Many of the ITS culture's technical creations are still alive today. The Emacs program editor is perhaps the best known. and much of ITS's folklore is still live to hackers, as one can see in the jargon file. SAIL and CMU weren't asleep either. Many of the cadre of hackers that grew up around SAIL's PDP-10 later became key figures in the development of the personal computer in today's window, icon, mouse software interfaces. Now, this is going to be interesting because at the time, the window, mouse, icon interface was revolutionary and innovative and like weird and crazy and wild. But the acronym that they're going to use for it is WIMP. Windows, icon, mouse. Meanwhile, the hackers at CMU, that's Carnegie Mellon, were doing the work that would lead to the first practical large-scale applications of expert systems and industrial robotics. So, expert systems is something you're going to hear a few times in this. And basically, it was the first attempt at AI in what we understand it to be here in 2024. And basically, the objective was to distill the decision-making capacity of, a human expert into a set of logical rules that you could apply to a problem. And while there was a certain measure of success, you certainly don't hear about expert systems nowadays, do you? Right? So, and that's because, computers are pretty black and white. They're cut and dried. There's not really room for, judgment calls and iffy scenarios and, situations where, there's not a whole lot of information to go on. Okay, another important node of the culture was Xerox PARC, the famed Palo Alto Research Center. And by the way, the Palo Alto Networks is actually still scanning the internet to this very day, mapping, for various reasons. So if you host a website, I encourage you to go in and check the access logs, or the web port logs, and I'm willing to bet you that you're going to see some request with the notation, this is from Palo Alto Networks. So Xerox, of course, Xerox PARC, the famed Palo Alto Research Center, for more than a decade, from the early 1970s until the mid-1980s, PARC yielded an astonishing volume of groundbreaking hardware and software innovations. The modern mice, windows, and icons style of software interface was invented there. So were the laser printer and the local area network. And PARC's series of D machines anticipated the powerful personal computers of the 1980s by a decade. Sadly, these profits were without honor in their own company, so much so that it became a standard joke to describe PARC as a place characterized by developing brilliant ideas for everyone else. Their influence on hackerdom was pervasive. The ARPANET and the PDP-10 culture grew in strength and variety throughout the 1970s. The facilities for electronic mailing lists that had been used to foster cooperation among continent-wide special interest groups were increasingly also used for more social and recreational purposes. DARPA deliberately turned a blind eye to all the technically unauthorized activity. So let's read that again. The ARPANET and the PDP-10 cultures grew in strength and variety throughout the 1970s. The facilities for electronic mailing lists, first mention of electronic mail, that had been used to foster cooperation among continent-wide special interest groups were increasing, also used for more social and recreational purposes. Now, here's an interesting thought. DARPA deliberately, knowingly, deliberately, intentionally turned a blind eye to all the technically unauthorized activity. So this is a Department of Defense research project network, and people are using it recreationally. And what does DARPA do? They're all like, hey, that's cool. I wonder what these guys are going to figure out. I wonder what these guys are going to do, and if it'll produce anything interesting. It understood that the extra overhead was a small price to pay for, and also this, for attracting an entire generation of bright young people into the computing field. It was the extra overhead, the extra electricity costs, the extra computing overhead was a small price to pay for attracting an entire generation of bright young people into the computing world. If you want to find, bright people, give them toys. I mean, that's the lesson there. If you want to attract people, who are going to invent new things, give them toys. And I don't mean Legos and like clay, Play-Doh. I mean, are our young people like, young people these days? Everybody's. I mean, come on, really? The toys they need are the toys that would be relevant to the business that you want them to do, the inventions that you want them to create. Not toys, real toys, big toys that are actually useful, things that they can make do interesting things that then have a business use, business purpose, that kind of thing. Perhaps the best known of the social ARPANET mailing list was the Sci-Fi Lovers list for science fiction fans. It is still very much alive today. See, some of these hackers, they're not going to improve the networking, technology necessarily because, for instance, it's needed for official communication, but they will improve it so that they can get to their sci-fi mailing list. I mean, take from that what you want. It is still very much alive today. That's not true anymore. In fact, on the larger internet, that ARPANET evolved into. But there were many others pioneering a style of communication that would later be commercialized by for-profit time-sharing services like CompuServe, Genie, and Prodigy, and later still dominated by AOL. So obviously he's dating himself. Your historian first became involved in hacker culture in 1977 through the early ARPANET and science fiction fandom. From then onward, I personally witnessed and participated in many of the changes described here. Okay, that's about as much as I can do in one sitting. So I'm gonna call it there, and maybe cut this together and put it up. Thank you for joining me. See ya.